This video is part 2 of your density notes. Today we're going to be reading on page 278, and we're going to continue kind of our reading from where we left off in part 1. In part 1 we covered how is density determined, and we learned about how to calculate density and what density is. Now we're going to be talking about sinking or floating. You just completed a sinking or floating prediction lab where you had to find the densities of different cubes and then predict whether or not they would sink or float in water. And you should have found out that if a block has a density greater than 1, then it would sink, and if it had a density less than 1, it would float. And we're going to find out, why is it 1? Well, that's because you found out in the lab before that the density of water is 1 gram per milliliter. So let's go ahead and read this and then just get what we've learned from that lab down into our notes. Suppose you have a block of wood and a block of iron of equal mass. When you drop both blocks into a tub of water, you see that the wood floats and the iron sinks. You know the density of water is 1 gram per centimeter cubed. Objects with densities greater than that of water will sink. Objects with lesser densities will float. That's what you should have found out in your lab. The density of water is 1, so if our blocks were greater than 1, they were sinking, and if they were less than 1, they were floating. So let's go ahead right now and add that over to our notes. So I'm just going to notice I tabbed it back out, and we're going to put sinking or floating. So when comparing objects with different densities, the object that is less dense will float. Now, the reason why we didn't necessarily say water is because, in science, we might not always be dealing with water. We might be dealing with 2 different liquids, or we might be dealing with a different type of liquid substance other than water and a different solid. So we always whatever 2 objects we're going to see if one will sink or float in another substance, we just have to compare their densities. One important fact that you probably do just need to memorize is that water's density is 1 gram per milliliter. So just to kind of give you an example of how we're not always going to be using water, I have a YouTube video for you. So in this video, this man has a cannonball, and he is going to drop it. This is what mercury looks like. If you remember, this was actually an element on our periodic table. It is a metal, and at room temperature, it's actually a liquid. So we're going to be comparing the 2 densities, and so I just want to give you an example of what it might look like when you're not always dealing with water. So don't really have to worry about the sound. He's not saying too much, but in a second he'll drop it in. Notice how it floats. So that means that the density of the cannonball has to be less than what the density of mercury is. And so if we look up the density of mercury, you find out that the density of mercury is 13.6 grams per milliliter. So compare that with the density of water, 1 gram per milliliter. And so the density of mercury is way, 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 way more dense. So that's why a cannonball would sink instantly in the water, but it's actually going to float in the mercury because that liquid is so much more dense. It's actually one of the heaviest liquids known. So there was just kind of a cool little side note for you guys to see. Let's go ahead and go back to our reading. So in this last paragraph here, watch a bottle of oil and vinegar salad dressing after it's been shaken. You will see the oil slowly form a separate layer above the vinegar. This happens because oil is less dense than vinegar. So up to this point, you guys have been working with seeing how solids will float in liquids or sink in liquids. We can actually do that with two liquids. We can see why one liquid will sink in another and why other objects will float. And so oil has to be less dense than water, or than vinegar, I'm sorry, because the vinegar is actually sinking down to the bottom and the oil will float on top. So let's just add that little example to our notes. Oil floats on vinegar because it is less dense than vinegar. Now, in your next lab, it's actually a mystery investigation. You are going to actually have to go through and you're going to have to use this concept of sinking and floating with liquids to help you solve the mystery. So you can go ahead and move on to your lab now.